Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the formulas that are used for all of the different types of annuities. Before we actually take a look at the formulas, let's just talk about the characteristics for each of the types of annuities. First of all, the definition of an annuity is equal payments at regular intervals. If those payments are at the end of the interval, it's called an ordinary annuity. If the payments are at the beginning of the interval, it's called an annuity due. And then each of these is further divided depending on the frequency of the payments and the frequency of the compound periods. If the number of payments per year is equal to the number of compound periods per year, it's simple for both types. An example of that is if you were making monthly payments and the money was being compounded monthly. So both of them would be 12 payments a year and 12 compound periods per year. On the other hand, general annuity, either ordinary or annuity due, is when the number of payments per year does not equal the number of compound periods per year. An example of that would be something like a mortgage, where you could be making monthly payments, so 12 payments a year. However, the mortgage is compounded semi-annually, so there's only 2 compound periods per year. So when they're not equal, it's general, again, for both types. So let's start off with the first characteristic of when the payment is due. So if the payment's at the end, it's an ordinary annuity. If it's at the beginning, it's an annuity due. Then our next characteristic is the frequency of the compound periods and the payment periods. If the frequencies are equal, it's a simple annuity. And if the payment is at the end, it's an ordinary simple annuity. So for an ordinary simple annuity, future value will equal payment times, in the numerator, 1 plus I, where I is the interest rate per compound period. All of that is raised to the power of n, where n is the total number of payments, minus 1 over I. The formula for simple annuity due is very, very similar, with just one additional factor. Future value is equal to the payment times the same expression as here. But in addition, we multiply by 1 plus I. The reason we do that is because the payment is at the beginning of the interval. That gives us 1 extra compound period. So that factor adjusts for that extra compound period. Now let's take a look at the 2 annuities where the frequencies are not equal. So let's first of all look at the formula for ordinary general annuity. The future value will equal the payment times, in the numerator we have 1 plus I to the exponent cy over py, where cy is the number of compound periods per year and py is the number of payments per year. That's raised to the power of n, where n is the total number of payments, minus 1 over 1 plus I, also to the cy over py, minus 1. This formula also works for ordinary simple annuity. If p per y and c per y are equal, and we put those in, we just get an exponent of 1. And then when you simplify this with those values equivalent, you'll get this formula. The future value for a general annuity due is very similar to this formula, but has 1 extra factor. Let's take a look. So for a general annuity due, the future value is equal to the payment times this same expression here, then multiplied to 1 plus I to the cy divided by py. Again, the reason we have this factor is because with an annuity due, the payment is at the beginning of the interval, so we have 1 extra compound period, so this factor adjusts for that. So here are your future value formulas for the 4 different types of annuities. If you'd like examples of how each of these formulas work with real numbers, you can take a look at some of my previous videos where I have covered each of these with examples. In addition, I've done videos where I show you how you can use your business analyst calculator to do the calculations for you instead of using the formulas.